I am Kadirova. I am from Uzbekistan. I work Bukhara State University. My topic is called Regression Analysis for Sustainable Waste Management in Uzbekistan. Waste management has emerged as an increasingly critical issue for Uzbekistan as a nation transitions toward sustainable and environmentally responsible economy. Rapid urbanization, accelerated industrial growth, and rising consumption patterns have significantly increased municipal solid waste generation, placing substantial stress on existing waste management infrastructure. Despite recent advancements in waste collection and recycling, a considerable portion of waste continues to be disposed of in unmanaged, unmanaged landfills or in informal dumping sites, intensifying environmental and public health risk. Next slide, we may see PG1 percentage of total waste generated per region in Uzbekistan and municipal solid waste disposal on land number of sites in 2017. Figure 1a illustrated the regional distribution of municipal solid waste generation across Uzbekistan, indicating that over 7 million tons of waste were produced in 2022. Tashkent, the capital city, accounted for the largest share, followed by Samarkand and Andijan. Such regional disparities emphasize the need for tailored waste management strategies addressing distinct local conditions. Additionally, Figure 2b provides an overview of municipal solid waste disposal sites by region, differentiating official landfills from unofficial dump sites and documented disposal location. Notable regions such as Tashkent, Samarkand, and Fergana exhibit higher numbers of disposal locations, many unregulated, further complicating sustainable waste governance. Next slide, you may see trends in total industrial investment volume in Uzbekistan over the years and investment distribution across key industrial sectors. Uzbekistan's rapid industrial expansion has notably influenced waste generation trends. Industrial production dramatically increased from 38.1 trillion Uzbek sum in 2010 to 658.9 trillion sum in 2023, reflecting compound annual growth rate of approximately 14.7%. This substantial industrial growth directly correlates with rising waste volumes, not only from production processes, but also from increased raw materials and energy consumption. In 2016-2023, industrial output grew nearly sixfold, from 111.8 trillion sums to 658.9 trillion sums. This article outlines the approach used to analyze municipal solid waste generation in Uzbekistan based on key socio-economic and industrial predictors. We describe the data sources, variable selection, and the statistical modeling techniques employed. We utilize multiple linear regression and multiple polynomial regression to explore the relationships between MSW generation and various factors. The validity of the selected model is supported by multicollinearity check and uh, an analysis of regression coefficients and standard errors. Pages number 3, evolution of municipal solid waste management in Uzbekistan, represented as ternary diagram of landfilling, recycling, and removal coverage. The trend shows a shift towards increased recycling and broader waste collection services over table number 1. uh, the data set used in the study consists of annual data from 2014 to 2024, covering multiple socioeconomic and industrial predictors related to municipal solid waste generation in Uzbekistan. The variables included in the analysis are uh, uh, municipal solid waste generation, population, foreign foreign tourists, GDP per capita, and the investments volumes in billion sums. You may see table number 2, regression coefficient, standard errors, and significance levels for the MLR model predicting MSW generation. Our results scatter plot showing the relationship between the predictor variable and MSW generation with a linear fit overlaid on the observed data points. The fitted linear function is displayed on the plot, along with the p-value indicating statistical significance and the Pearson correlation coefficient measuring the strength and direction of the correlation. Figure number 5, a scatter plot showing the relationship between the predictor variable and municipal solid waste generation with a polynomial fit overlaid on the observed data points. The fitted polynomial equation is displayed on the plot, capturing the nonlinear relationship between the variables. Figure number 6, the KDA plots comparing the distribution of actual MSVW generation values and the predicted values for the multiple MLR model and the MPR model. The R-squared values indicate the goodness of fit for each model, with the MLR model achieving a near perfect fit and the MPR model showing a slightly lower but still strong correlation. Table number 3, comparison of model performance metrics for MLR and MPR models. And policy implications. The statistical results carry important policy implications. First, the strong effect of the population growth suggests that Uzbekistan's waste management strategy must scale collection and recycling infrastructure proportionally with demographic expansion. Without proactive investment, service gaps will widen as cities grow. Second, the role of GDP per capita highlights the importance of addressing consumption-driven waste. Economic growth is increasing demand for packaged foods, beverages, and consumer goods. Third, the industrial correlation highlights specific waste-intensive sectors. And finally, the moderate but significant influence of tourism suggests that seasonal waste management strategies should be adopted in higher tourism regions such as Samarkand and Bukhara. Waste infrastructure must be flexible enough to accommodate sudden surges in demand. Thank you for attention.